Hello everyone, welcome to Up to Permission. Today we are going to discuss the very important topic, that is the spectroscopy. Okay, in this video I will try to cover the overall meaning of spectroscopy, then what is meant by the electromagnetic radiation, various type of interaction, then characteristic of the electromagnetic radiation, and the last one is the interaction of this electromagnetic radiation with the molecule. Okay, so let's start with the meaning of spectroscopy. You know that the spectroscopy means what? The interaction, okay, interaction of electromagnetic radiation with the matter. Okay, suppose this is the electromagnetic radiation. Electromagnetic radiation maybe our light. Okay, and this is the substance, chemical substance or drug substance or matter. Okay, and the interaction is happen with this drug substance. You know that in the lab we do the practical of UV, IR, NMR, and we do the sample of this sample testing, and we use various type of drugs. In the pharmacies practical, in the analysis we use the paracetamol assay. Okay, just like that we use the sample like that, and we call it as a matter. Okay, so the interaction of this electromagnetic radiation with the sample happen in a different manner, and this interaction disclose the so much information, and this will be useful for to identify the chemical structure of the drug, the mass of the product, molecular weight of the product, and the nature of hydrogen atoms. Different type of information we get from this interaction. So we try to understand how which are those interaction. The first one is the interaction that is the very basic, that is the absorption of the electromagnetic radiation. Okay, now next one is the reflection, third one is a refraction, fourth one is a transmission, fifth one is a emission of electromagnetic radiation, or sixth one is the scattering of light. Okay, these are the different type of interaction happen with the this drug substance. Okay, now we try to understand various type of spectroscopy. There are two types of spectroscopy. Okay, first one is the atomic spectroscopy, and second one is the molecular spectroscopy. Okay, atomic spectroscopy means what? Atomic spectroscopy means what? The interaction of electromagnetic radiation with the atom means atomic spectroscopy, and the interaction of electromagnetic radiation with molecule is called as molecular spectroscopy. Spectroscopy is very simple to understand: atomic spectroscopy, molecular spectroscopy. In the molecular spectroscopy, you know that the spectroscopy such as UV visible, then IR, then NMR. Okay, these are the molecular spectroscopy. And in atomic spectroscopy is atomic absorption spectroscopy. Okay, these are the type of spectroscopy. And now next part is that the characteristic of electromagnetic radiation. Okay, electromagnetic radiation having a wavelength. Second one is the velocity. Third one is the wave number. Fourth one is the frequency. And last, that is the energy. Okay, these are the characteristic of electromagnetic radiation. You know that the wavelength is denoted by the lambda, velocity is denoted by the v, wave number is the lambda bar, for frequency we use the nu. Okay, for the frequency we use nu, and for energy we use the E. Okay, we try to understand the step by step the meaning of the each term. You know that the what is meant by the wavelength. So to understand, I will draw the wavelength. See, this is the wave. You know that this is the wave. This is the one wave. This is the second wave. Okay, in the wave, the upper part, okay, and this is the lower part. In one wave, there is the upper part and this is the lower part. For upper part, we call it as a maxima. Okay, and for the lower part, we call it as a minima. Okay, This upper part maxima we also called as a crust, okay, CRUST, crust, or for lower part we also called as a trough, okay. So I want to tell you that the meaning of wavelength. Wavelength means what? This is the second maxima, okay. See, this is second maxima. Wavelength means the distance between two maxima or the distance between two minima is called as wavelength. The distance between two maxima or the distance between two minima, we call it as wavelength. And the wavelength is the unit of wavelength is per centimeter, okay. This is the unit of wavelength, okay. Now velocity means the distance traveled by the wave. This is the one wave, and the distance traveled by the one wave in 1 second is called as a velocity, okay. And you know that the velocity of air is 3 into 10 raised to the power of 8 meter per second, or 3 into 10 raised to the power of 10 centimeter per second, okay. This is the velocity of light, okay. Now this is the wave number. What is meant by the wave number? So now we try to understand what is meant by the wave number. See, this is the wave, okay. Suppose this is the wave. See, this is the 1 centimeter, this is the 2 centimeter, okay. The number of waves in 1 centimeter is called as wave number. In the 1 centimeter, how many waves are there? This is the first wave, this is the first wave, and this is the second wave, okay. So there are number of waves. There is a 2 wave in 1 centimeter, and that means that the number of waves in a 1 centimeter we call it as a wave number. And you know that the wave number is always inversely proportional to the wavelength. Means wave number is inversely proportional to the wavelength. Therefore, the unit for wave number is a centimeter. Okay, unit for wave number is a centimeter. Now next the frequency. Frequency means what? Frequency means, suppose we take a specific point. Suppose this is the specific point, okay. The number of waves passing through a specific point, the number of waves passing through this specific point, specific points, we call it as a frequency, okay. Number of waves passing through a specific point in a 1 second is called as a frequency, and the unit for frequency is hertz, okay. The unit for frequency is hertz, okay. Suppose 1 kilohertz, 1 megahertz, or 1 gigahertz. 1 kilohertz means 10 raised to the power of 3 hertz, okay. 1 megahertz 10 raised to the power of 6 hertz, okay, and 1 gigahertz 10 raised to the power of 9 hertz, okay. The most important unit for the frequency is the 1 megahertz is 10 raised to the power of 6 hertz. Why this is very important? Because in NMR spectroscopy, most of the time we use the megahertz unit, okay. And you know that in the market, the NMR instrument available in the megahertz frequency. In the Naiper the instrument available, that is the 500 megahertz, okay, and the 600 megahertz, okay. These two instruments available in the Naiper of NMR, okay. The last and most important that is the energy, okay. What is meant by the energy? Energy, you know that the light, or we also call it as photon, the energy stored in the form of photon, okay. So the basic and the very famous equation, that is E is equal to mc square, okay. And this unit is discovered by the well-known scientist, that is Einstein, and we also call it as the Einstein equation. In this equation, E means what? E is energy, okay. M is mass, and this is the C square is the velocity, or this is the one unit. Now next, we also call as E is equal to h nu. and this unit is very important in the spectroscopy. Okay, E is equal to h nu. So in this equation, E is energy. What is meant by h and what is by nu? H, very important. H is a Planck constant. Planck constant. The value of Planck constant is what? The value of Planck constant is 6.626 into 10 raised to the power of minus 34. Okay, joule second, and also we call it as 6.626 into 10 raised to the power of minus 27 erg second. Okay, these are the two value for the Planck constant, and the very important. Now next is the nu. Nu means what? Nu means frequency. Okay, you know that frequency. And now this equation we also write like this also. E is equal to hc by lambda. Okay, in the place of nu, frequency is a direct frequency always direct proportional to the velocity and inversely proportional to the wavelength. So the unit, so now the equation is E is equal to hc by lambda. Okay, this is the Planck constant, this is the velocity of light, and this is the wavelength. Okay, unit for wavelength is per centimeter, for velocity centimeter per second. Okay, for Planck constant, we can calculate the unit by shifting this wavelength and velocity in the left side. Okay, this is the energy equation, and the energy equation also we look at the the Avogadro number into h nu. Okay, this is also the unit of, this is also the equation of energy. Okay, now this is about all about the spectroscopy. Now we try to understand how the interactions happen of electromagnetic radiation with the molecule. Okay, and this is the very important part. Suppose we taken an example, C double bond O, C H H H. This is the structure of 1, 2, 3. This is the structure of propanone, and this is the ketone. By using this chemical structure, we try to understand the various aspects of the spectroscopy. Okay, see, these are the bonds, or is also called as a functional group, that is a carbonyl functional group. And in this carbonyl functional group, there is a vibration of bond is happen. Okay, what is the vibration of bonds? Vibration. It is a vibrational spectroscopy, and you know that the vibrational spectroscopy, what is the IR? IR is the vibrational spectroscopy. Okay, so now this for IR. You know that on the carbonyl there is a unpaired electron are present. Okay, this unpaired, and this is the conjugation. This is the unpaired electron present. Okay, these unpaired electrons or lone pair of electrons, they absorb the light, and due to the absorption we call it as absorption spectroscopy. Absorption spectroscopy, and that is the UV spectroscopy. UV spectroscopy is absorption spectroscopy. Now next, you know that this is hydrogen. These are the different type of hydrogen. Okay, and for this 3 hydrogen, the environment is same. For 3, the environment is the same. Okay, so you know that the hydrogen, or we also call it as a proton, they rotate. So what is the rotational spectroscopy? Okay, there's a spinning of this proton is happening. Okay, so we call it as a rotational spectroscopy. Rotational spectroscopy, and you know that the rotational spectroscopy and this we use the nuclear magnetic resonance, and it is a magnetic waves we use for this spectroscopy. And there are 2 types of NMR. First one is the proton NMR, second one is the carbon NMR. These are the 2 types of NMR, and this is the rotational absorption spectroscopy, and this is the vibrational spectroscopy. This is a very simple to understand. This is the overall of what is meant by the spectroscopy. I hope you understand very well what is meant by the spectroscopy. So thank you for watching, and if you are new on the channel, please subscribe the channel and press the bell icon. So thank you.